They should, right? Okay. It's not like, well, when we put 3 in place for x, we usually get 7 back for y, but sometimes weird things happen. You get like 15. If that was the case, then it wouldn't be a function. This is a function because every time I put 3 in place for x, I'm going to get 7 back out for y. It's not like I put 3 in for x and I get multiple outcomes. I'm going to get the same consistent, unique output every single time. Okay? This grows quickly into a lot of different things. Linear functions, those are easy to see because we work with them all the time. But again, it can start to get a little bit more complicated as the functions grow a little bit more, or as the potential functions grow more and more complicated. We have this scenario, I guess, built in. I think that it's a good one to talk about because I'm sure that I'm not the only person that checks the weather apps and stuff like that. Does anybody else do that on a regular basis? Okay. Like every day, I think I look at, okay, what's the temperature today? And I like to know, like, what's, based on what I've got going, well, what's the temperature at 4 p.m.? What's the temperature at 5 p.m., at 6 p.m., at 7 p.m., that sort of thing? Is it going to be raining, that sort of thing? But if we just focused on the temperature, is it possible that throughout the day, the same temperature shows up at various times? That's okay, isn't it? Not only is that okay, but that happens literally every single day. Okay, if you were to take out your phones right now and if you were to look at the weather apps, I'm sure that a couple of the different times are going to have the exact same temperature. That's fine. That's not a problem. What would be a problem or an impossibility is if you looked at your weather app and it said, yeah, at 3 p.m. it's going to be 84 degrees. But it's also going to be 62 degrees, and it's also going to be 95 degrees. All in the same location. It's going to be all 3 of those temperatures at the same time. No, it isn't. That doesn't make any sense. Like that's impossible. That's not the way things are going to work. At this time, it's this exact temperature. Now, at different times, it could be the same temperature. Who cares? No big deal. Okay? But at no point do I have this input that leads to various outputs. That's where we have the potential problem. So again, when we're looking at this diagram displays a function. Some people may look at this initially and say, well, wait a second, 3 and 4 are both leading to 15. That's fine. It would have been a problem if 3 led to 15 and 3 led to 12. That's when it would have been a problem. How are we feeling about functions? It's all coming back here a little bit. We remember some stuff. Okay, functions, I would say more commonly than, rectangles drawn with circles and arrows. More often it's going to be in this format of ordered pairs, where we have our x term and we have our y term, okay? Kind of like what we were trying to display up there, what they really represent. So what do we think? Is this relation going to be a function that has these 6 coordinates? Yeah, hopefully what you're looking at here are the x values. You're looking for some repeating x values. We didn't have them. We had 6 unique x values, so we're good. This is going to represent a function. Now, if I had a 7th that was located at 5, 20, then it's not a function anymore because we've already established that 5 leads to 12. 5 can also lead to something else. All right? So we've got some characteristics of some functions. I think we've essentially already covered every bit of this, but this is the very technical sounding textbook definition. So if you're only somewhat am joking, but if you're having trouble sleeping, go ahead and read through that a couple times. But again, I do find value in knowing what's the book version versus what's the translation of how does that actually sound, because you're not too far away from sitting in a college lecture hall, whether it's in a math class or a science class, to where you're probably going to have to read through the book and kind of evaluate this and kind of figure some things out. Not that you won't have professors or assistant professors to help you out, but there's going to be some level of, well, read the book and figure it out. So I'm not doing that to you, but I want you to start to get used to seeing it that way, I guess is what I'm trying to say. So back to this, we want to determine whether or not a relation is a function. In order to do that, like I said, we've got to identify the input values, make certain that they're leading to one unique consistent output value. When any input value is matched to 2 or more output values, it's not going to be a function. So what do we think about this first one in example 5? A on the left side. Function, not a function. What do you think? Not a function. What's the problem? I think we could... The negative 1?
Yeah.
Yeah. What's the story, negative 1? Are you leading to 3 or are you leading to 4? Because it can't be both. Okay? Is this a problem here that both 1 and 2 are leading to 5? Is that a problem? No, that's fine. No big deal. All right, what about B? We were in table form here. Again, I'm looking at the inputs, 0, 1, 2, 3, and 4. I'm noticing no repetition. So what does that tell me about the function or potential function? Yeah, this is a function. All right, guys, I was hoping that we'd have a little bit more time, but again, 3 or 4 minutes is going to be better than nothing. The good news that we've got here on function notation. Again, from time to time, students get a little apprehensive or nervous when they see function notation because it sounds so official. But you're going to hear the word notation a lot in math. It just means how you write stuff. So how can we write functions? You all experienced it at some point last year. All of a sudden, just one day, everything was y equals this, y equals this, y equals, and then all of a sudden one day you showed up and it was f of x equals f, g of x equals that, right? It's just that you started to get into function notation. Now, x is going to be your input, f of x is going to be your output, which leads to that function of that equation of that form. But again, this is going to be our function notation. Now, we can start to evaluate functions. I know that you've seen this before, but again, some students will potentially, freak out a little bit maybe when they see the structure. If we're looking at f of x equals, we'll use the same one, it looks like 1 minus x squared, and our task, our job is to evaluate or find f of negative 1. So what that means is f of negative 1, that means that we quite literally are going to put a negative 1 in place for x. Everywhere we see an x, we're going to put a negative 1, and then we evaluate. So if we're evaluating f of negative 1, we've got 1 minus negative 1 squared is 1, 1 minus 1 is 0, so f of negative 1 is 0. Understand what we just established, or what we just claimed, was that when we put a negative 1 in place for x, we got a 0 back out for y. All right, does that make sense how we got there? Now, what's going to change when we jump over here? I'm going to skip over one. And we now want to evaluate, well, what's f of 3? So what's different? What changes? I'm not putting negative 1 in place for x anymore. What am I going to do? I'm going to put a 3 in place for x. So as we clean that one up, we've got 1 minus, I know that 3 squared is 9. 1 minus 9 is negative 8. So now f of 3 equals negative 8. Which means that when I put a 3 in place for x, I got negative 8 back out for y, which leads to that coordinate. Now, I know that I skipped over f of 0, but we feel like we could do that as well. Okay? The last one, what if we are looking at something like that? All right, yeah, we've got 3 terms, no big deal. But we understand exactly what would happen on g of 2. Are we going to put a 2 in both of these places, wherever we see the x? Okay? The last one, don't have time to do, but g of x plus 2. Now we're going to put an x plus 2 in place for the x's as well. All right, so let me pause this video.